Hi. Today I'm going to explain RSA encryption, which is the typical algorithm that your computer uses to send encoded messages across the internet. First, let me use an example to explain the purpose of RSA. Let's say you want to pass a secret message to your friend in class. If you just write your message on a piece of paper and the teacher sees it, she could read it. And perhaps she'll read it out loud to the entire class, which could be terribly embarrassing. The point is, you don't want your teacher to be able to read it. So what you can do is encode your message. Here's a simple encryption method where each letter is represented by its spot in the alphabet and space is 27. Then you can encrypt your message and your friend can decrypt it by doing the reverse of what you did. But if your teacher intercepts the note, she won't be able to read it unless she knows how to decode it. Now, let's say you're a bank and you want people to send you their bank information safely. If everyone uses the same encryption method, that is, everyone gets the same key to lock their bank information, then one person could use their key to unlock somebody else's lock and steal their money. This simply won't do. And it wouldn't be feasible to give every one of our thousands of clients their own special key in person. What we need is a method that is easy to lock but hard to unlock. And this is what RSA is for. RSA works like a padlock, where everyone can put the padlock on their private information, but only the bank has the key to unlock the padlock. So if someone tries to steal someone else's information, they won't have the key. You depend on RSA every day to keep your information secure. Banks use it, Google, Amazon, Facebook. The modern world depends on RSA. If RSA were broken, all of your information stored on these websites could be stolen, which would have a catastrophic effect on both your security and the world's. So now that we know why RSA is so important, let's take a look at how it works. But first, we must learn modular arithmetic, also known as clock arithmetic. Luckily, you already have a basic understanding of clock arithmetic. Let me give you an example. If Bob goes to work at 9 o'clock and then works for 8 hours, what time does he get home at? That's right, 5 o'clock. But 9 plus 8 equals 17, not 5. However, we can notice that 17 is equal to 12 plus 5. And on a 12-hour clock, every time we count up to 12 hours, we reset our count back to 0. So we can effectively ignore the 12 because it gets reset back to 0. And this is what modular arithmetic is. If we ignore all the multiples of 12, then 17 is the same as 5. We say this as 17 is congruent to 5 mod 12. And we can express this using an equal sign with an extra dash. The nice thing is we can easily calculate these congruences because when 17 is divided by 12, the remainder is 5. We can generalize this idea for clocks with any number of hours, say n. We reduce a number x mod n by finding the remainder when x is divided by n. And here's an example problem. Reduce 487 mod 32. To solve this problem, we can just use long division. And here's the work.